We're back, so let's proceed with chapter 1. First full chapter. Maybe before we proceed, just a quick note for those of you well, just a bonus for those watching this video. So you might notice that some concepts have links to the docs, and if you click them, it's going to point you to the proper documentation. What some people might not notice is that there are links in the method calls, the function calls. So say load image, it's going to go directly to the definition of the function. Anyway, let's proceed. So for this chapter, we're going to go on how to draw objects for our sprites. If you're not familiar with sprites, there's a Wikipedia page for that. And how to move the objects in our game. So sprites, game loop, and basic physics. Anyway, let's start with drawing basic sprite. So we're going to draw this asset bullet.png. So what's that? So this is this. It's a small bullet. We're going to draw that bullet somewhere in our game. So first we load the asset, the preload function. So to preload the asset, then when we're going to use it, we're going to call add sprite and store the sprite definition in a local variable. Yeah, it's not a local variable, it's an object variable. Okay, so let's start. Again, for those of you just watching this, please don't copy paste because you're not going to learn, but I'm not here to learn, I'm here to teach. Anyway, so first let's preload that. And the sprite bullet. Right, so we copied it and load sprite, add sprite, this adds the XY coordinate. And if we refresh our page, it's there. The background is scrolling, but it's there. And there's no error. What just happened is that we loaded a bullet and we put it at 400 and 300, and the coordinate system that we are using is the screen coordinate system. So if you've taken math in high school, you should be familiar with the normal Cartesian coordinate system. So the x is normal, x goes to the left, but going up, normally the y coordinate is going up, but for screens the y coordinate is going down. So if you look at the screen, it should look like this. So the top left would be 0 0, top bottom would be 800 600, and the center where we put our bullet is at 400 and 300. The x is 400, 300 is that. And you just didn't notice how we decided upon the size of the game. That's that. Set the size to 800 by 600. Should fit most screens. The previous version of this book used 1024 by 768. Then based on the analytics, I realized that a lot of people are using 1366 by 768, and that doesn't fit their screen. So I shifted the size down to 800 by 600. And as you can see, even when zoomed a bit, it still is within the size of the screen. Anyway, back to our topic. So we now know how to put a bullet in our screen. But before we proceed, just a quick note about the phaser examples. You've opened the phaser examples like this one. You will note that there is a slightly different syntax for adding sprites or doing anything, practically anything. So in this case, we directly use this that adds sprite, but when we look at certain examples like this one, the first example, which loads the image, it loads Einstein's mug. Here we see that they are using game that add that sprite. The difference here is the loading, how the game is loaded. Here, the game is loaded using this style, directly adding an object and directly adding the callbacks or the functions here. But for our case, we do it differently. So our style is in the template. This is more modular. So instead of adding, again, the actual object that would define the functions, the game loop functions, which we will discuss a bit later. Now you have states. Those states are individual objects, and those individual objects are added at our game object, and they are started using game.state to start. So the difference is here in our game now have our game functions. So the game, when it's the game is added to this state is added to the game, stuff is done, and we can define these things. And the thing that is done is it sort of injects. So this basic game. So if you see this game state add, this will call the constructor, basically the constructor of the game class, game object. There's no classes here in JavaScript. And here the game object is inserted within the instance of the object. So instead of having us do this game that added sprite, in this style that we're using, this modular style, we can do that instead with that game that added sprite. Because if we don't use include this, there's really no reference to game inside the context of our functions. So here, there's no game there, but compared to the other example, this thing has a game within its context because it's visible in this context. But in our case, it doesn't. So instead, it's injected. The game reference is injected. So yeah, long story short, instead of using game that add that sprite, all instances of game is shortened to just this. Okay, so if you see the original game template, the game.js, you will see this lines. So instead of calling the game.add, just call this dot. It usually works that way. So yeah, which exactly what we did. Anyway, so that's it for the Cartesian coordinates and the basics thing about phaser, how you call the phaser functions within the states. Let's proceed to the other one, drawing animation. So we drew a simple sprite here. Let's draw a simple animation. So instead of loading an image, we now load a sprite sheet. Again, you can click these things and it will point you to the definition. Let's just delete this quickly. So yeah, instead of loading images, we're going to load the sprite sheet. So what is a sprite sheet? It's an image containing multiple sprites. So it's a sheet of sprites. If you open enemy.png, you can see that. So that's that. It's just a sheet of Sprite. And if you look at it, this is basically that. So the magenta is the transparent part of the image. So loading the sprite sheet is similar, just define how big it is, how big each sprite is within the sprite sheet. So let's add this one. And we play the animation. Here, you got this enemy, add sprite, add it, same horizontal, same x coordinate, but a bit higher from the bullet. Then we add an animation, define what the animation is. So the sprite sheet starts with 0, the frames start with 0. So each sprite there is essentially a frame of the animation. So start with 0, 1, 2, then we loop it. 0, 1, 2, loop it. And let's say it's I think this is 20 frames per second. And the true is the loop. See if it's 20 frames per second. No, it's a different call. The animation call is slightly different. Animations add. Just go do a quick animation. Then wait. So Sprite, it has the animation manager. Go to animation manager. So yeah, frame rate, the speed in frames per second. So that's how you would look up the methods inside the documentation. Anyway, then we set that animation to fly, and we just play the fly. So again, realize now that what you're doing here in loading is you're loading the asset and giving it a name. Didn't mention that before, but here you see asset, set it to C, bullet, set it to bullet. This entire sprite sheet named enemy, we set it to green enemy. Similarly, in the animations, we define an animation and we gave it a name fly, because later we're going to see multiple types of animation, and once defined, we can now play the animation. Just do a quick example of that. It should be before C and bullet. We're going to see later that this order is quite important. And yeah, quite important. And refresh it. So now, there you go. It's animated. I think I'm recording at 30 FPS, so you can't really see the full 60 FPS if you stop the video. Anyway, again, that's that. That's for that. We now can add the image sprite, then we can add an animation sprite. A sprite that has an animation and play that animation. Alright. Next part is the anchoring. You realize that we added both at the 400 and the x coordinate as the 400 mark. It should have been in the center, but instead of being in the center, it's not quite at the center. That's because the sprites that we add have a default anchor at its top left. So what we see here is that this part where my pointer is not 400 200. This part is the 400 200 because that's the anchor point. Similarly, it's not as obvious here, but the anchor point here is in the top left. To change that, we can just simply set the anchor of our sprite. So the anchor has an X and Y. So if you set, it's by default it's 0 0, which means top left. If you set it to 1 1, it's bottom right. So we want it to be anchored at the center. So we replace this with, we add this as 0 0.5, 0 0.5. Paste this. Then refreshing it, it's now anchored correctly. Yeah, just quick note about anchoring. Anyway, that's it for drawing images and animations. Let's proceed to the next part. So game loop. This is how Phaser works, because if you notice the game programming patterns, so if you watched this before I finished the the video for this section, again going back here, most games use this pattern, the game loop. And if you want to learn more about the game loop, I suggest just read this. But point is, in Phaser, the implementation of the game loop is as such. Got your preload. If the state starts, so you got multiple states in your game, and we got 4 of them. Each state has different functions which define each part of the game loop. So you got your preload. There's also another higher, I think that's in it, but we're not going to cover that. Preload, usually there's all the assets there. After preload is finished, go to create. This is the initial setup for the game, and again, that's what we did here. And finally, the actual game loop is update and render. By default, this loop is done at 60 frames per second, so 60 times per second. So again, if you realize you've got a preload, this is called, then the create, then every 1/60th of a second, update and render are called. Update first, then render. So that's how games work, and if you want to know why, again, there is the game programming pattern for that. So yeah, so now we have an overview of that thing. Let's use that knowledge to move our bullet. So one way of moving the bullet is through the update function, because again, the update is called every 1/60th of a second if possible. If there's a lag, there's going to be some other stuff that's done, but point is, every call of the update is going to be called. So like this one, the C moves slightly downwards every 1/60th of a second. So now we are going to do that with the bullet. So the bullet is a sprite. Yes, it's working. Yay. Yeah, it's a bullet. It's a sprite. If you want to learn more about the sprite, again, there's always the API if you want to know the members. So there's the X and there's the Y. So if we want to change its X coordinate or Y coordinate, so in this case, every call of the update, we want the Y coordinate to decrement. It's going to be smaller per update. So it's going to go up here. Because again, that's what we want. We want to move the bullet. So we save that. Save that, and play. It's now inching up. And I think I'm seeing stutters now. Maybe because of WebGL. Let's try changing this to it's still stuttering. I think this is just a problem with our think this is a problem with our virtual machine. There's really nothing we can do with that. Anyway, so that's that. That's the basic way of moving your object. So for each update call, you change the coordinate, and usually that's what you do in certain frameworks, especially frameworks that don't have what Phaser has, and that we will discuss in a while. Okay, so that's update render. Might notice that we don't have a render function here. So look, no render function. In Phaser, you don't really need that, because Phaser, unless you're doing something special, which you will do in a bit, you don't need to do that. So it's automatically done. And okay, there's a car outside. Yeah, so what Phaser does is it has its own render calls in the backend. You don't see the other render calls. You can define your own render call. It's going to call at this part, but the other renderers will be called differently. So you don't really, for the most part, you don't need to define the rendering function. Usually you need to define the update function, but again, render is not that important yet. Alright, that's that. No render function. Let's proceed with the physics. So Phaser comes with 2 physics systems. Previously it was 3, now it's just 2 because not a lot of people use the other one, Ninja Physics. We're using is Arcade. P2 is much more complicated, but allows you to do a lot of things. But Arcade is good enough for us. And it's a lot smaller download size compared to the other. So yeah, anyway, back to what we want to do. Instead of doing this bullet y-1, we use the arcade physics to set the physics details of our sprites. And what's that? So we set the velocity to -500. So that's 500 pixels per second. That's 500 pixels per second, and it will automatically calculate what it needs. So we're going to delete this. So pixels upwards, frame per second, 8 to 9 pixels per frame. So refresh this. So yeah, it's now faster. And we don't need to play around with the update. Just set the physics, and the physics engine will do the update for us. As you saw here, physics update, it's done for us. Anyway, so again, if you yeah, that's the physics. So let's proceed. So the main difference with arcade and P2 is that arcade is very, very simple, which makes it quite fast and smaller than the other, the P2 one. So with arcade, we only have one type of collision checking, and that's ABB, axis aligned bounding box. So each sprite has a bounding box. You can define this bounding box, and we're going to discuss that way later. But by default, it just has a bounding box that is a square. P2, you can define how the regions look like, but for arcade, just simple, just boxes. So let's just see the debug of the body, because later you might want to know how what's the problem, why some objects aren't colliding. If you want to debug that, it should be easy using this call. So we just call this in the render. Okay, so first off, since you also want to see the body, the debug of the physics body of our enemy sprite, we also enable it. So physics enable this enemy, and here you can see again, this is where the fun starts. You can now see the location of our, there's also a space here. So this is, again, this is the first time we saw the line numbers, because here you might have, again, like what happened here, I missed a white space. This is the part where with the line numbers you can realize what went wrong with your copy pasting or manual copying. What the hell? Anyway, so that's that. We now have a render because we want to render the body, the debug body of our physics objects, our sprites. So yeah, you now see that all of the body, all of the physics bodies have this green thing around them. So that's the debug rendering. So that's what you're going to do if you're having problems with physics. Anyway, so let's proceed with the collision. So if you want to do collision, you can just use this overlap. This is overlap checking, and you define the sprite and you define another sprite, then the function, the call, essentially the callback that will be called if those sprites collide. So here you got your bullet and your enemy. You overlap check if the bullet object overlaps with the enemy sprite, and if it collides, we call this new function that we will add. Let's copy it, update. And also we copy paste this. 42. Hopefully the macro thing will work later, because it's going to be a lot easier for me to remove the line numbers. Anyway, line 42, 45, so it's correct. So again, overlap, it's going to call enemy hit, and it's going to call the kill function. Kill function will not free the memory, it's just going to make the remove the visibility. It's going to make the object invisible, and yeah, just kills it, marks it that it's also marks it as dead, because there's also health and living and existing checking in phaser sprites. Yeah, so it's too fast, maybe it's too slow, but in the screenshot we have here usually stops at that if you have a faster computer, not this virtual machine. So again, that's what happened. So each update, so each frame, so here we got it correctly now. So each frame it will check whether it overlaps, and if it overlaps, it's going to kill both. So yeah, this is a callback. It requires two two arguments and just kill those two. And at this point, we can now remove the debugging part. So you don't need it. Anyway, next part is explosions. Explosions. This is fun. The new sprite sheet. Got 6 frames. But since the 6 frames doesn't have an extra frame, so this has an extra frame that we will use much later. And we don't need to loop the explosion. We can just call this animation add without any additional function calls, because by default it's just going to use all of the frames, runs it at 60 frames per second, and won't loop it. So first, again, we preload the sprite, name it explosion, reload. And next is let's add this lines of code, the actual explosion, right? And we then set the other settings on the actual play itself. So we want to slow the explosion down, and there you go. Let's try it now. So we did this in the enemy hit. So not only do we kill the bullet and the enemy, we now also set an explosion animation at the location, former location of the enemy. So let's do a quick, so it's there, boom, boom, boom. So that's the animation, basic animation, basic how to do things, and again, X and Y, enemy has X and Y, and so on. Next part, we're now going to create our player and how to control it.